Hello everyone. So welcome to the next lecture. What we were discussing last time was industrial sector. So let us continue our discussion on the industrial sector, and what I told you very peculiar about the industrial sector was that is not only the energy which is the troublesome factor here, that it is not only about the energy consumption, it is not about only just moving from the fossil fuel based energy sources to non fossil fuel based energy sources. It is also about the process emissions also, which is bothersome, and that is why we need to go deeper into understanding the process related issues also when we are trying to decarbonize the industrial sector. So that is what we were discussing, and what we were discussing last time was that why energy efficiency alone is not sufficient, and why energy efficiency is only a very partial measure in the whole game of the decarbonize the industrial emission, because it will not impact you so much, because energy is not the prime reason for this emission here. What was also talked about was that even when we move to different processes, the energy reduction may not be possible beyond a point, because that high temperature requirement, because of other requirements in the whole domain. And that is why CCUS, which was the carbon capturing, and also material efficiency and things like that, which was primarily talked about as one of the major things which this sector needs to focus on, and we'll go deeper into these aspects, like I'm not concluding it here. Another issue which this industry faces is asset lock-in issue, as was the case in power sector also, and as I've been mentioning this issue again and again, is that asset lock-in is a big issue in this whole transition to net zero emissions, because assets has been bought and assets have a long life, assets have certain ROIs. Just to take that call of not utilizing those assets to its full life can be a real challenge. So typically industry facilities operate for several decades, and that's how their depreciation is kindly accounted for. The whole profit and loss journey which industry has been kind of working on, the kind of EBITDA or anything else that industry has been working on, has taken certain amount of depreciation. So suddenly writing off that equipment will have a direct impact on the bottom line of that company itself, right. So but what can be potentially done in this is that there is a cycle to this industry, and if we can catch the next wave, if we can be ready before the next wave of change of this industry comes in, specifically here this curve is for steel sector. When we go to steel sector, we'll look deeper into this issue, but there is a cyclic kind of investment which goes into this sector on a 25 to 30 year or 40 years kind of a basis. So if we can capture the next cycle, when the next cycle is expected to pitch in, if we can catch that cycle, potentially we will have a good chance of moving and cutting into some energy efficient technologies and moving into some other processes also, which could be much less chemically intensive process, which will have a direct scope 1 kind of an emission, right. So but if we delay this catching up this wave, so technology has to get ready by that time. So that's the main point. And if we miss this next wave of this cut-in of assets, which is expected to come in next few 10 years or 15 years or whatever is the cycle, depending upon country to country, if we miss this next wave, so then again the assets will get locked in for 25 to 30 years. So that's a tricky part for this sector, right. So just to tell you a bit about the investment cycle logic. So what happens is that industrial decarbonization will depend upon the timing of the capital stock turnover. So how usually it works is that you do capital investment, so then you start selling the goods, you generate cash, then you purchase some more equipment, you install them, then again you produce, then again you sell, and this is the operating cycle where you work, that you kind of you give out cash, the cash goes as outflow, you purchase equipments, you install it, you start producing it, and you start selling it. And now once you start selling it, there will be a cycle where you will again take a decision to invest again. Once you start selling, you will start making some money around it. So either you will go for a capacity enhancement, or you will go for upgradation of technology, or just the equipment will have its useful life ending. So you will need to bring in new equipments to kind of continue this cycle. So you will have to take some decision at certain point of time, where again you will go into this capital investment cycle, where you will be ready to sell lot more cash. So what you really want to do is that when you are ready to take this next decision, at this point you should be able, with a new set of equipments which you want to then install, which will be more energy efficient and less chemical intensive. So missing these windows will significantly increase the long term mitigation plan, because again once the installation has been done, to uninstall that becomes a very, very tricky subject to discuss. And if you look at it, that why this is so important is that because if you just look at the how much investment is required for this transition, roughly that's what some of the analysts have kind of worked out. It's just for the low emission industrial production assets, $2.1 trillion might be an asset requirement which might have to come in. And additionally, 4.2 trillion will be needed for installing new power systems, hydrogen system, CO2 storage. So the CCUS technologies and all those things. So a lot of investments will need to go into this sector very soon if you have to decarbonize the sector. And if you don't do it at the right time, this high investment which is needed and missing that cycle would be kind of a double whammy, if I can talk that way. Because this money what we are talking about is that this money is almost double the investment that is going into energy sector of $1.9 trillion in 2021. See, we are not talking about a small money here. So we are talking about a big chunk of money. And if you look at it sector by sector, steel sector would probably need the highest kind of investment because steel sector depends upon very high energy intensive processes. The furnaces are huge. When we go into the technology, we talk about BOF and we talk about the technologies which are used in steel sector, and just to make the transition from very heavy coal based technology to electrical furnaces or to methane based furnaces or some other route or hydrogen route or whatever we need to talk about would require almost an entire change of the process itself. So that cycle will become very, very important, and steel sector is looking for a huge investment around this time. So this infrastructure to asset ratio is almost 7.3 times. So whatever is the current industry assets, so you are talking about almost 7 times the investment in the assets which industry will need to pump in. So that's a huge chunk of money which we are talking about. Similarly, ammonia also would need a very significant kind of an investment. One sector which is kind of looking decent from that perspective is cement sector, because here it's mostly the crushers, it's mostly the conveyors and all those things, which is pretty standard. So you don't need to do much over there. But what we need to do is probably invest a lot on CCUS, because a lot of direct emissions with respect to using the processes which directly emit the carbon dioxide is prevalent. To mitigate that, maybe CCUS would be the biggest thing that this industry would need to kind of invest in, and also some kind of a clean power requirement also goes. But if you look at the breakup of this industry, CO2 transport and storage would be the kind of a highest thing for this specific industry. If you look at the steel industry per se, it is mostly the clean power, because that's where mostly the emissions are coming from in this industry. So it will depend on sector, but overall the message which I am trying to give you here is that the investment needed in this sector is not something insignificant. It's a very, very significant, which this sector will look as an investment. And for some of the sub sectors within this whole domain of industrial sector itself, like particularly for steel and for ammonia, this could be a tricky topic for discussion, because steel sector is talking about almost 7 times of its asset value to be pumped in this sector, and who will put in that money, where will that money come from is a big debate which is bound to happen. And on top of it, if we don't do it at the right time, we might again miss that bus, and that kind of a issue will kind of continue to prevail, right? Some further infrastructure constraints which will come is with respect to technology availability, because if you look in terms of the technology availability, we are talking about 3 things out here. We are talking about carbon capture, we are talking about clean hydrogen, we are talking about the clean power. So if we just start breaking it up, the total requirement for net zero industry in 2050 in terms of clean power is just some estimated is about 1665 gigawatt is the total power requirement, and that clean energy is expected to be available. So from the energy side, with the whatever development is happening on the solar and wind and those sectors or those technologies, it is expected that the clean power would be available. So clean power should not be a challenge for this sector. The challenge which is expected is in clean hydrogen. If you look at it currently, also clean hydrogen is very, very low, and also it's very, very expensive. Cost of clean hydrogen is very expensive. And while this industry is betting big on clean hydrogen, so would clean hydrogen be available in 2050 is another challenge which this industry will have. So there's a lot of technology uncertainty, and which is built in the whole assumption of this industry transition. So, and another, as I've talked to you before also, overall industry is betting quite big, if you like, specifically with respect to cement, if you look at it, and steel as a second thing that you look into it is on the carbon capture. CCUS they are betting big on CCUS overall. And CCUS is not an easy technology to, like, it's at least as of now when we talk, not very cost-effective CCUS solutions has been demonstrated. Not very cost-effective solution of CCUS has been put in terms of reliability of technology. Also, CCUS still is a unproven technology overall. So, and while this industry is betting so big on this whole CCUS as a technology availability, so this kind of puts a big risk in terms of this transition also, because while we are talking about doing at the right time, will the technology will be ready at the right time for right kind of deployment at the right cost is a big challenge and big if for this industry, right. But overall, if we talk about that, what will be needed would be a system level approach for this industrial net zero. What would like as I kind of mentioned it earlier also, but kind of putting it in a kind of a circle, we will need to work on demand pattern. We will need to work on manufacturing processes, we need to work on energy systems, we need to work on infrastructure, we need to work on finance and policy things. So, overall what will happen is that what is produced, how it is produced, what energy is used, and what it contributes to, and then we need to kind of work on it that whatever is emitted, how are you kind of capturing it afterwards, right. So, it is a kind of a complete cycle, and none of them we can work in isolation. This whole ecosystem has kind of worked as a very coordinated joint wheel for this thing to kind of follow. That is why this has been put in a kind of a wheel shape here, because then for wheel to continue to move, none of the things can have a bump, or none of the things have kind of perturbation also. So, all of them has to work in quite in sync to kind of reach where we want to reach. If we just take a quick snapshot of where are we today, like while we are talking about all this transition, which transition has to happen both for energy as well as for process as well as for carbon capture. Transition has to happen on all the three angles, and it has to happen at the right time, at the right cost, and it has to, a lot of money has to go into the system, it has to be kind of a coordinated effort. Where are we today? Like, so if we then start looking into the current status of the whole sectors. So, if you look at sector by sector, this analysis was done by World Economic Forum, where they started looking into this from a technology development perspective, infrastructure readiness perspective, how the demand is responding to this, how the policy to support low emission is working on, and how the capital is in this whole sector is kind of flowing in. And obviously, as you can understand, the green is something where we are ready, and red is something where we are still struggling, or we are not ready at all, or it is looking challenging. So, if you start looking into it, steel sector specifically, technology is showing some signs of improvement, but if you as soon as you start looking at infrastructure, that is a red, policy support is a red, capital infusion is a red. Only thing which is responding rightly in the steel sector, and when we go into this sector we will look into this more, is probably on the demand side to produce low emission products at a premium price is something which is looking interesting, and I will show you why it is looking interesting also. But that is something which is looking quite interesting from that perspective. Similarly, we can look at all the sectors, and probably the sectors which is looking the least red is the chemical sector, ammonia sector per se, where only thing which is worrisome is the demand side. And when we go to the demand side of it, I'll tell you why the demand side of this side is looking a bit tricky. But as you can imagine, this is primarily going into agriculture sector, and the paying capacity of the farmers will come into picture here. So, we'll talk more about this. But if you look overall, steel and aluminum are looking decent from the demand side, cement is iffy in between, ammonia is looking bad. But the biggest challenge, which as you can imagine, is what you can see is surprisingly is on the policy side. Even the coherence in the policy right now is challenging. Like, while we all understand it, and we think that everybody from a policymaker's perspective will understand this perspective, and they will start responding to the whole changeover plan, which the way it needs to be done. There you start looking into that still a couple of sectors are not supported by policy changes, the kind of aggression or kind of policy changes which needs to be brought in. There we see challenges, and capital infusion is a huge challenge. And while we are talking about this sector needing more capital infusion compared to the power sector overall, whatever we had in power sector in 2019, or whatever number we are comparing it with, that the huge capital infusion which is needed, and the capital confirmation for this sector looks very challenging. And without the capital infusion, even if the technology is developed, how will it will launch? How the infrastructure, even if it is developed, how it will be launched, how it will be changed if we are not ready to put in money in this. So, that is another challenge, and which later in the course I will also try to touch upon this point deeper, that while with all the intent that we are talking about, still the money flow in this whole domain is looking challenging overall, right. Just looking in terms of technology readiness versus deployment, that was the first vertical. In terms of ammonia, the technology readiness from a blue hydrogen perspective, they are betting on blue hydrogen, and that seems to be ready. That seems to be almost ready. For the steel sector, around 2025, it was expected that DRI, electrical energy based EF with carbon capture will kind of get rolled out. So that's kind of a almost there. It's still there are some challenges around it, but it has been kind of rolled out. So at least one technology barrier we are kind of crossing when we are looking into this here technology barrier, which was looking yellow. It will start looking green or slightly less yellow very soon. Aluminum sector also is looking interesting from that side, because at least partial technology is expected to get developed around this time itself. And hydrogen furnaces is expected to come in next 5 to 6 years is what is expected in this sector. Cement, however, since it primarily depends upon the carbon capture, that is still waiting for technology development, and it is expected that later around this decade itself, some technology breakthrough is expected to come. Let us see how it kind of gets rolled out. But the bigger challenge which will come is that whenever the technology is developed, will it be commercial availability of this low cost deployment or large scale deployment of these technologies will be possible or not possible? What will be the infrastructure constraints? What will be the cost gaps? What will be the investment risk? And they will remain as major barriers when this technology starts to kick in also. And as you can see from the previous slide, the costs looks challenging. So how will the investment number looks challenging? So how will that investment number will kick in by the time will challenge. In terms of demand optimization strategies, so as I said, that demand wise, steel was looking interesting, aluminum was looking interesting. And so there is definitely some work going on the demand side, both on the demand optimization as well as moving to the clean produced goods. So overall demand for these sectors is expected to grow, because as you know that these are the basis of the whole development cycle is. But what is being done is that efforts are on that can we reduce the expected growth in this sector by putting in some net zero emission policies around demand. So in aluminum, some alternative to aluminum is being worked out, or through design interventions, the processes are going on that can less amount of aluminum be used for a specific use, and which can lead to a situation where we can then have less use of aluminum itself per se. So that is being worked out. On the ammonia side, again some demand level interventions are being worked out. But what is looking very interesting is cement sector, because alternative building technologies, alternative materials are being worked around for cement, which is leading to a situation where if they all get kicked in, we could be looking at a situation with all the like when there is a saying which goes around that half of the world is still to be built, and for that cement is expected to play a huge role. But the way policies are being developed, the way the behavioral changes or the alternative technologies are being developed, it is expected that if all that get kicked in rightly, we could be looking for kind of a flattish growth in this sector is something which will be very interesting. And this will come through some design regulations, incentive to promote longer lifetimes overall in this whole thing, demand management, substitutes. Substitutes is a big thing, like for a cement industry, for example, when we are talking about building construction, alternative materials are being talked about now, which could potentially replace cement as one of the binders or one of the or just reduce the amount of cement which is needed for per wall, or the amount of cement which is needed per bridge. That is being worked out a lot these days as a technology thing. A role of from a policy side, that's where the things can slightly starts like where do these things go, and we need to understand that where do these things go will kind of determine that what kind of policy interventions which will have to be kicked in. Like so, steel primarily goes partially into transport industry. Industry itself consumes steel because they are building around it, but a lot of steel goes into buildings, right? For the cement industry, it is primarily around the infrastructure or the building or the built up environment which goes. Challenge is in the ammonia sector, and that's where we start seeing some challenges, because on the ammonia side, the primary demand is on the agriculture, and as you can imagine, to do something on the agriculture sector side will not be that easy a challenge for anybody, right? So agriculture practice they influence fertilizer and ammonia demand, and to do something on that end would be a tricky part to do because of the sentiments which are attached to it, which is that part of the society which is anyway deprived of lot of modern amenities overall. So to touch that sector itself would be a challenging thing. And but on the other hand, if we have to really work on this, and if we have to really go towards this demand kind of a management, where we are talking about ammonia to be reduced, where we are talking about other things also to be reduced, we need to continue to work and bring in the right policies to manage it, right? But what is also being done in parallel is specifically with respect to steel and aluminum. So what is being done is that target is being taken both on the maximum potential emission reduction in the primary production also, as well as on the secondary production also. Secondary production would mean that can you start recycling or reusing the material itself, or so recycling steel and aluminum generates significantly lower emission compared to primary production, and that's where a lot of emphasis is being done, that can aluminum and steel as a material can be brought back into the ecosystem and can be brought back into the manufacturing industry somehow through collection route, through some other routes. If it can be brought in and it can be reused as a material, when we go into the sector we will understand it more. But if we could do that, and if we can also power it using the renewable energy sources, we could potentially be talking about a significant portion of these materials being produced through almost through zero emissions as far as the energy goes. Like process related emissions will also be reduced a lot, because then you're not talking about melting those materials where the maximum emission goes. You will have a material which will be ready, which needs to be reshaped, repurposed. Even if it needs to be melted, it will be melted at a much lower temperature. It will be through much lower processes. You are not going into fundamental process of taking a kind of a iron ore and converting that into a kind of a usable iron. You're not talking about that. You're talking about a process where you will be using kind of a processed steel or processed aluminum, which needs to be repurposed, reshaped, and remade for the new use. So expanding recycling is one of the fastest mitigation option that we have overall. And so that is being worked out a lot in this industry, while emphasis is also being done on the primary production reduction, emission reduction also. And with primary production reduction, emission is being talked about the things which I talked to you earlier, which was through alternative energy, CCUS, and hydrogen is primarily being worked around on the primary emission side, right? So in terms of the energy consumption sector, what it has is that steel is probably the highest energy consumption overall. So if you look at steel, which is the highest energy consumption right now, electrification of the fuel mix has a potential. Aluminum has a potential, while aluminum is not as energy intensive. So steel is the most energy intensive sector if you kind of go into it. And today the sector rely on fossil fuel. Further efficiency gain, energy efficiency gain can be realized, but as I have already talked to you about, that energy efficiency per se may not play that big a role. So fossil fuel emission can be mitigated through substitution of low carbon energy sources, switching from coal to biomass or electrification of plants. But overall, what is being worked out is that there is a limited potential of energy reduction which can potentially be done in this area, specifically with respect to ammonia, for example. With respect to cement, there is not much of data, but cement anyway will depend upon CCUS per se a lot. So overall, energy sector will play a role here, as further 40% emission still come from energy, but not for all sectors. Specifically, energy will play biggest role in steel, for example. It will not play such a big role in aluminum, and as we saw that it will have its own limited role to play in cement sector also. If you look at the current progress towards low emission production, the sector overall, if you start looking sector by sector, so this graph you need to look into from that perspective, is that how much emission intensity was expected to reduce by 2030, that is given by blue line, and how much emission intensity is expected to reduce by 2050, that is given by green line. As we saw a few slides back, we were looking at more than 95% emission reduction in most of the sector, so somewhere 95%, somewhere 100% kind of a thing that we were looking into it. And if you look into the current targets around 2030, overall the sector, what it was expected to achieve at 2030 targets, we have made some decent progress on that line. Specifically, the sector which has made some decent gain is on the aluminum side. Aluminum has made some decent kind of a moment. So if you look at the movement of aluminum, that is looking interesting. Steel is started to look interesting also, and that is primarily, as you can imagine, this has primarily happened because of use of the secondary material. We'll go deeper into this when we go into this specific subsector analysis also. But steel and aluminum starts looking interesting. Cement and ammonia, however, has not made much of the progress. ammonia more because of the demand side issue, because it is the demand of the new material which is not getting picked up, and cement because of the CCUS issue, because CCUS becomes it still remains kind of a black box for this transition to happen. So it is from a sectoral perspective, and aluminum per se is holding on to its promises more than anything else right now. But this is another way of tracking it in terms of that how each sector is kind of started to work around while you start looking into this data deeper, right? On the demand side, the challenge, let us understand these challenges before I end today's class, is that when you move from a normal material to a green material, so you need to then break this whole thing into two parts. One is the cost of the material itself, and one is the cost of end use. What is the end use price changes compared to the change in the material price itself? Like for example, if per ton of steel goes up by 38%, the amount of steel used in per car and whatever else goes in a car, because there will be air conditioner, there will be music system, there will be tires, there will be engines, there will be so much of electronics, there will be seats, interiors, whatever needs to go in the car, with all put together, even if the steel price goes up by 38%, the net impact on the car is less than 1%. So from a user perspective, for the end user perspective, they don't feel the pinch. They don't feel it that they have been impacted. On the other hand, if you look at ammonia, if 55% changes happen on ammonia prices, the per ton of fertilizer prices will change by 25%. And so this starts becoming tricky. Like cement also 67% change here per house, whatever goes into a house, only 3% change you will see in the house side. Per ton of aluminum, maybe 40% changes on the aluminum, per car basis you will see less than 1%, right? So what you will need to see is that how much it is changing for the material price and how much it is changing for the end user price, and that's where the demand picture will come into play. So if you remember a few slides back when I was talking to you about this, ammonia, the issue was coming from the demand side, and this is the reason why it is coming from the demand side, because the end user impact on the prices is much higher. Of course, end user prices premium may look smaller, but it may accumulate around the value chain. So there are other things which can also start getting built in, like from a housing perspective, for example, if steel starts to go up, if the cement starts to go up, if the aluminum starts to go up, so if you start all putting it together, it may start to look much more aggressive. But for most of the uses, it will happen that the end user may not get impacted so much, except for ammonia in this case, right? So overall, rising fertilizer and energy costs directly affect food security. It impacts farmers, which are anyway struggling to meet their ends. So what can happen is that government is expected to manage these impacts by ensuring socially equitable transitions is what will governments needs to do. But so you can look at this picture from two sides. You can look at this picture from one side, that strata of the people who can pay, people who can buy a car, people who can afford that cost of a car, for them 1% or 2% impact will not mean much, right? And that's where probably this green steel cut in and green aluminum cut in, for per se, even sometimes for many houses, which are, because housing category will have a huge variation with respect to who is buying that house, but from a cement perspective, the impact may be a bit limited, but it will start getting very, very tricky when you go into ammonia kind of material, which directly goes into farms, which directly goes into fertilizer. So we'll continue to look into this industrial sector. There's much more to talk about in this industrial sector while we talk, and so see you in the next class, where we'll go deeper into this industrial sector, and then we'll start moving into the steel sector per se in the next class itself. Thank you, and see you in the next class. Bye-bye.